Ensemble methods. Random forest is an example for an ensemble method. First, let us see ensemble methods in general, then we will look into random forest. In ensemble methods, instead of using just one model, we will be taking results from more than one model and go for the best best result. So in ensemble methods, we use multiple models to obtain better predictive performance. Combine multiple learners to produce a strong learner. Typically, much more computation will be involved since you are training multiple learners, and it combines multiple fast learners like decision tree. Why decision tree is called as a fast learner? From the data, it's very easy or fast to prepare the decision tree. So the learning process is done very fast. And once the decision tree is ready, the prediction also will take only little time. But ensemble methods sometimes tend to overfit, and it tend to get better results since there is deliberately introduced significant diversity among the models. There are two types of ensemble methods. First one is called bagging. It's a short form of bootstrap aggregation. Each model in the ensemble votes with equal weight. Train each model with a random training set. In bagging, you can assume your data set is inside a bag. You can take out the training set for the first model from inside the bag by keeping your eyes folded. Then you prepare the first model with that training set. After training, you keep back those data set inside the bag, and again, keeping your eyes folded, take another set of samples from the bag and use it for the second model. So the data set used for the different models are random data sets. The algorithm used for the first model can be KNN, second model can be logistic regression. Like that, you can use n number of models and n number of algorithms. While doing prediction, say out of 10 models in an ensemble model, 6 are predicting the class of one test record as category 1, and 4 are predicting that class as category 2. We will go for the maximum voting one, like we will predict it as category 1 because maximum number of models are predicting that record as category 1. So this is how we do bagging. Bagging is one technique used in ensemble methods. Second method is boosting. In boosting, what we do is we will prepare the first model and find out which are the classes it has wrongly predicted or where it is going wrong. And we will apply a boosting so that this error will not be repeated. For example, if in the iris species prediction, if one species is not at all predicting properly, we will increase the number of rows of that particular that particular species in the training set and make sure that that particular species is correctly predicted. So in boosting, we can say it is an incremental algorithm. We make many models, but when we build new models, will try to do better on previous models misclassifications. You can better it by increasing the accuracy. Here also it will tend to overfit, and because we may be increasing the number of samples of a particular type. Okay, then AdaBoost is a example of a boosting algorithm. It's a most frequently used boosting algorithm. Random forest. A forest is considered as a collection of trees. In machine learning, a random forest is a collection of decision trees. In an ensemble method, when we combine only decision trees, we can say it is a random forest algorithm. The mathematical definition of a forest is a collection of trees. Or when we remove the root node of a tree, what we get is a forest. So when we have a large number of decision trees as part of an ensemble model, that algorithm is called as random forest. Features and advantages of random forest. The advantages of random forest are: it is one of the most accurate learning algorithms available. For many data sets, it produces a highly accurate classifier. When we compare different models for a same data set, we will find that for many of the data sets, random forest will give you maximum accuracy. It runs efficiently on large databases. It can handle thousands of input variables without variable deletion. It has an effective method of estimating missing data. And you know that if some data is missing from our data set, it won't affect a decision tree. So it is having a effective method of the missing data, and maintains accuracy when a large proportion of the data are missing. Actually what happens is the branches corresponding to those missing data will not be there, but our decision tree will be perfect. It has methods for balancing error in class population unbalanced data set. Generated forest can be saved for future use on other data.